Talked about slope last time. The slope of a line is a number. When I think of slope, I think it's a number that we can assign to the line as an indication of the steepness of the line as well as the direction. It's a signed quantity, could be positive. Lines with positive slope we're going to think of as slanting upward to the right. As we consider the graph, lines with negative slope, we're going to think of slanting downward to the right. And the next example we'll look at, a line will have a slope of 0, and that will indicate a horizontal line. And a line that's vertical, we cannot assign a slope to because it involves dividing by 0. So let's recall the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the four general cases, positive slope, we think of rise over run. Positive divided by positive if we're going left to right and down to up. And so the slope is a positive divided by a positive, which is a positive. If you switch it and go from the upper right to the lower left, then both the rise and run would be negative. And that would be a negative divided by negative, but it's also positive, so positive slope either way. A line that slants downward to the right, like that, it's going to have a negative slope. If we go from point to point on the line, and we go to the right, that's positive run. If we go downward, though, that's negative rise. And the slope would be a negative number divided by a positive number, which is a negative number. If we're going from the lower right to the upper left, the rise would be positive in that case because we'd be going up. But if we're going to the left, then the run would be negative. So that would be a positive divided by a negative, still making it negative. Now, the case which we'll look at next, if the line is horizontal, and that doesn't look as horizontal as I can draw it. One more try. At horizontal, straight across, a little better perhaps, straight across the line, if you go from point to point, you could encounter positive run or negative run if you go to the left, but the slope would be 0 divided by, you pick either a positive or negative number. Well, we don't want to divide by 0, but if we divide 0 by a positive number or a negative number, then we get 0. Go ahead and say it's 0. So we say the slope is 0 or 0 slope, not the same thing as no slope. If there's a number, even 0, that we can assign to a line and say that's a description of the slope, the steepness and the direction, then we do so. And we can. In this case, we cannot. In the case of a vertical line, whether we're going down to up or up to down, we can encounter a non-zero rise, but not a non-zero run. So the slope is positive divided by 0, and that's undefined. You could say no slope, and I really don't like the expression no slope because it's so easily confused with 0 slope. But if you're going to use the expression no slope, make sure you associate that with a vertical line. Horizontal lines have a slope, it's just 0. So let's look at that example of a line with a slope of 0. The line goes through the point -4, 3, and the point 2, 3, right there. If the 2 points have the same y coordinate, that tips us off to the fact that it's going straight across. No change in the y value. It's a horizontal line. If we use the slope formula, call one of the points x sub 1, y sub 1, and call the other one x sub 2, y sub 2, and the slope formula would have us write 3 minus 3, the 3 on the right minus the 3 on the left, over 2 minus -4, 0 divided by 6. You would be surprised at how many folks on my most recent intermediate algebra test did not know that 0 divided by whatever was equal to 0. I think it was 0 divided by -9 is how it worked out. Go ahead and call that 0, otherwise you would not get full credit for that because it leaves some doubt in my mind. Are they thinking it's 0? Are they thinking it's undefined? If it's 0, call it 0. So the slope is 0. If it's undefined, the picture will look like this. vertical line. There's 2, 4. There is 2, negative 3, I guess right down there. 2, 4, 2, negative 3. And M, technically we're not even supposed to use the slope formula if it's a vertical line. The official slope formula, basically, this is valid only if x sub 1 is different from x sub 2. If the x's are the same, the formula doesn't even make sense, but I'm going to use it and we'll see why it doesn't make sense. Negative 3 minus 4 over 2 minus 2, and we get negative 7 divided by 0, which is undefined. Can't divide by 0. If you divide by 0 and call it anything, you can't check your answer with multiplication because multiply back by 0 and you don't get whatever that non-zero numerator was. So this is undefined. Undefined slope is the best way to say it. If you must use the expression no slope, that's fine. But I would take it a step further and say no slope at all. Just doesn't have one. There's no number we can assign to the line and call that the slope. So, there we go. So the 4 cases. Now, if we know the slope of a line, an indication of how steep that line is, and any point, any starting point on the line, that uniquely determines a line. If we pick a point, say pick the point 2, 1. I can copy this. Pick the point 2, 1. There are a lot of different lines that go through the point 2, 1. Oh, you can see it's the point 2, 1. I don't think I want to label it. A lot of different lines go through the point 2, 1. But if we specify how steep the line has to be, we don't have a lot of choice. To get from one point to the other, that's going to determine the steepness, or be determined by the steepness. So to graph this line, that's enough information to graph it. If the slope is 3/4, how are we going to find another point on this line? Up 3? Right 4. Up 3 and right 4. If we get to another point in such a way that between the 2 points the rise is 3, positive 3, the run is positive 4, then the rise over run would be 3/4. That takes us to the point 6, 4, it looks like. If we add 4 to the x coordinate, 2 plus 4 equals 6. If we add 3 to the y coordinate, 1 plus 3 equals 4. That's really enough. If you've got a straight edge, you can connect the dots and have the graph of that line. If you want to continue the process, 3 more up, 4 more to the right, that would take us here to the point 10, 7. Or if you want to continue, if you want to go the other direction, 3 over 4, if you write it like that, the 3 means 3 up, the 4 means 4 to the right. You could also write 3/4, well, a lot of different ways to write a fraction, but just two probably most useful ways for us here. Negative 3 over negative 4. In that case, the negative 3 means what? Down 3. And the negative 4 means 4 to the left. For the left. So from any one of these points, if we go down 3 and 4 to the left, that too would land us on the line. So hopefully if we connect all these dots with a straight line, it would be the straight line whose graph we are attempting to form here. And it continues like that. So here's the graph. We'll refer back to this just a few moments when we look at finding equations of lines. We'll come back and see if we can find an equation for this particular line. Graph the line that passes through the point 3, negative 2. Slope, it's maybe ever so slightly easier to deal with if that's possible. The slope is 0. What kind of lines have a slope of 0? Horizontal lines. So to sketch the graph of a horizontal line, that shouldn't be too tough. We could plot the point 3, negative 2, and then any other point that's straight across from that, so long as we give it the proper y coordinate, we should be fine. So that's 3, negative 2, and that's 0, negative 2. I could connect those dots like this and this, and just it asks us to write an equation for the line. So in the spirit of doing that without some sophisticated formula or form for coming up with an equation, just make some observations. Other points on the line: 5, negative 2, 6, negative 2, 8, negative 2, negative 4, negative 2, negative 10, negative 2. I just want to write an equation that describes every point on this line. What do all the points on this line have in common? Negative 2. The y coordinate is negative 2. So an equation for this line could simply be y equals negative 2. This is the set of all points in the plane that have negative 2 as their y coordinate. And that describes this line. And most equations of lines that we have an x term and a y term. This one doesn't have the x term because when the x value changes, it has no effect on the y term. All we need to know is the y coordinate's negative 2, and it's a point on this line. Now there's a little blurb that appears in the notes. I wish I had grabbed that there. Paste that and shrink it down. In general, when we want to write an equation of a horizontal line, good enough there. In fact, I can probably cover up that portion of the graph. There'll be situations where it says write an equation of the line. Well, if we have enough information to determine that it's a horizontal line, maybe it just comes out and says it's a horizontal line, then we know it's of the form y equals a constant, or can be written that way. We just need to find the y coordinate of any point on the line, and we'll have ourselves an equation. Similar for vertical lines. Not exactly the same, but close enough, I think. Graph the line that goes through the point 3, negative 2, and does not have a slope. Slope is undefined. So we know this is a vertical line if it does not have a slope. So 3, negative 2 is on this line, and you ought to be able to use the MyMathLab straight line graphing tool to graph this. It won't let you plot a whole bunch of points, but if you just want 2 points on this line, if you go with 3, negative 2 is one of them, what's another point in this viewing window that's on that line? What do you think? So many to choose from. I know it's hard to pick just one. 3, 0. Yeah, the x-intercept is a good one to pick. 3, 0 is on this line, and it has an x-coordinate of 3. I'll go ahead and sketch the graph, connect the dots. We know it's vertical. Could have also gone with 3, negative 6, or 3, 7, 3, 10, or 3, negative 8. A lot of possibilities, points on this vertical line. If we were to write an equation, we just observe what all the points have in common. And all the points have what in common? 3 is the x-coordinate. There we go. So x equals 3. So as a rule, when we want to come up with an equation of a vertical line, just find the x-coordinate of any point on that line and write it in this form. And I did it again, but it's still no harm, I guess. I could put that up there. Like so. Have you seen the slope-intercept form of the equation of a line somewhere in your mathematical journey? Yes, at least one, probably 2 or 3 math classes you've had. You've seen the slope-intercept form of the equation of a straight line. Probably the most popular and arguably the most useful form of the equation of a straight line. It's the form we get when we take the equation and solve it for y in terms of x. On the left-hand side, 1y is all we have. On the right-hand side, we have an x term and a constant term, if there happens to be a non-zero constant term. It's particularly useful for finding the slope when the equation is known but the slope is unknown. And it's also useful once we talk about functions. It's a little bit of foreshadowing here. We haven't officially defined what functions are, but when we get to the point where we're talking about functions, if we can solve the equation for y and pick up the y and replace it with the notation f of x, what will happen is we can express this as a function, give it a function name, and evaluate it like we would evaluate a function. So just basics in terms of the slope-intercept form and the definition there. Y equals mx plus b is the slope-intercept form. The slope is m, and the y-intercept, I go ahead and say here the y-intercept is b, and that seems to be consistent with what my math lab often asks for when it asks you to find the y-intercepts. I like to think of intercepts as points, but when it's specified that we're talking specifically about x-intercepts or y-intercepts, just the particular coordinate. So the y-coordinate of the point where the graph crosses the y-axis is b, and we call that the y-intercept. If we know the equation of a line and we do not know the slope-intercept form is very handy for figuring out the slope quickly. If you just think about it, y equals 6x plus 4, if we weren't thinking and comparing this to y equals mx plus b, and we wanted to know the slope of this line, we'd need to find two ordered pairs that satisfy this equation. Now, admittedly, they're not difficult to find. Just maybe plug in 0 for x, and then plug in 1 for x, and then do rise over run real quick. And you could do this for other equations that can be more difficult than that. But in this case, we just look at it, and we know the slope is what? 6, just like that. Because this equation is in slope-intercept form. So when it's in slope-intercept form, by inspection, we inspect it, and we see that 6 is the slope. Now, the equation here in the b part is not quite in slope-intercept form, right? Not quite there. What can we do to put 3y equals 12x plus 10 into slope-intercept form? Divide both sides by 3. Yeah. So 3y divided by 3 equals 12x plus 10, that quantity divided by 3. That gives us 1y on the left. And on the right, we take the 12x divided by 3, take the 10 and divide by 3, and y equals 4x plus 10/3. And once it's in slope-intercept form, then we just inspect the equation and see that the slope is 4. So if an equation is given, and sometimes there's an extra step, sometimes that x term is over there on the same side as the y term, and you have to subtract the x term from both sides. Maybe it's a couple steps rather than just one, as it was in this case. But that is an efficient way to calculate this, or to figure out, I don't know if I call it calculating, to obtain the slope if the equation is given. Example 6 is a little bit on the trivial side, I think, but we'll do it. Example 6, graph the line. I think really the point of example 6 is to emphasize that if we know the slope and we know the y-intercept, basically we have the slope-intercept form which gives us that information, then graphing the line should be as straightforward as plotting the y-intercept and then using the rise over run idea with the slope. So here, rather than using the given information, let's just imagine that we were given that the equation, well, oops, I messed that up. What's the equation of this line? Y equals what in slope-intercept form? So, yes, and I apologize for my equal sign here. For some reason, if I zoom in or zoom out just the right amount or the wrong amount, it makes that look like it's negative, but really m equals positive 1/2. So the slope, if you want to think of it like that, the slope is positive 1/2. So y equals 1/2 x plus 3. So this is you can think of this as the given information. So we plot the point that's given. Looking at this, the y-intercept is 3. And we could find another point just by going 1 up and 2 to the right. Feel good about the 0.24? Do it again. You feel good about the 0.45? Does that one look okay? Or go to the left. 1 down, 2 to the left. How about negative 2.2? Connect the dots. And we got the graph. Not something that's profoundly different from what we did with the one going through the point, was it 1, 2, 2, 1, and having a slope of 3/4. But it emphasizes that if we have the slope-intercept form, it's not too difficult to come up with a graph shortly thereafter. Did you bring your calculator today? Yes? It's a good day for you to have brought your calculator. What I would like to do is take the data found here and input this to the calculator and construct a scatter diagram, what it looks like, and then have the calculator give us an equation that comes as close as possible, equation of a straight line, that comes as close as possible to as many of these points as possible. And it's not this picture, because I believe these points come pretty close to being all on the same straight line. So let's clear that. Just clear that. Clear that. To get the process started, let's press from the main screen, press the stat button, kind of right there, if you can see it, in the middle toward the top, not at the top, but toward the top, the stat button. And then number 1 on the edit menu there, so it'll go to the edit menu. If you press number 1 for edit right there, it'll take you to a page that has L1, L2, L3 at the top. Is that what you see? Anybody not see the L1, L2, and L3? Stat 1, and it takes you here. You don't have to see any numbers. I'm going to clear these numbers out. But you do see the L1, L2, and L3. Now, if I didn't have many of these numbers, I could delete them one at a time, but deleting is dangerous on this screen. I'm going to suggest using the clear button. So if you have numbers there that from the previous problem, you don't want them anymore, you can move the cursor using the up and down arrows up to the L1 where it's actually sitting on the L1. Press clear. Looks like nothing happened. However, if you press the down arrow, then it will go ahead and indicate that that list has been cleared. You don't want to press delete. That's the scary thing when you press delete. If you press delete, D-E-L, the L2 goes away and panic begins to set in. What do I do when my L2 list has gone away? Well, if that happens, you can insert it. Just press the second button and the up above delete where it says INS, you can press delete again, and that will give you space to put it. And then down here on number 1, 2, 3, 4, 5, 6, you see up above that in blue or yellow, little L1, L2, L3, L4. If you then press second followed by the number 2, it'll put the L2 back there. When you press enter, then your list will be restored. So it's best just not to delete a list. Use clear, so I'm going to clear that one as well. I'm going to press clear, press down, and L3 is not really going to be in our way, but just to clean up the screen a little bit, clear that one and press down. I want to type these numbers. The X values are going to go in the L1 list, the 20, 40, 45, 65, and so on. I want to type those in going down the column there. So 40, and then 45, and then 65. Whoa. Go. Once you get to the 110 down there at the bottom, just press the right arrow, And it'll go to the second column, the L2 list, and type those y coordinates, 44. I can actually type it faster here. Okay, once I have them all in there, go back to the top. So you have 7 numbers, these 7 numbers in the L1 list, these 7 numbers in the L2 list. If there are any other numbers down below that, then it will mess with this equation a little bit. So you want to make sure that there are no numbers down below that. Individual numbers you can delete one at a time. You just don't want to delete the L1 or the L2. Now from here, I want to see if I can get the calculator to draw a picture of this. In practice, when you do the MyMathLab problem, you don't have to get the calculator to draw the picture, but visually, to see what we're doing, I think the picture is important. Press the second button, followed by the y equals button directly above it. Up above y equals, you see where it says stat plot. I want to turn a stat plot on. Number 1 stat plot. If it's not already on, press 1. I want to do more than just turn the stat plot on. We'll do that. And then indicate the particular type of plot. Anybody currently taking statistics? Statistics? No? Previously took statistics last semester, a couple semesters ago. Sometimes you use others of these, the frequency histogram or the box and whisker plot. We're just going to use a scatter diagram. That's the default when the calculator is fresh out of the box. That's what it's flashing on there. L1 is where we put our x coordinates. L2 is where we put our y coordinates. Anybody see a different list other than L1 or L2? If you have a different list, say for example, I wanted L5 in the L1 list, I can move the cursor to its flashing there and then press second 5. I don't want L5, I want L1. So I'm going to go to its flashing on the L5 and press second L1. There we go. Now for the mark, 3 choices. If we had just a lot of dots in the viewing window, maybe the dot would be best. But what I'm going to want it to do is draw a straight line, and it would cover up a dot if I put a dot. So I'm going to use squares, so that when it draws a straight line, it might cover up the corner of the square or go right through the square, but we'll still see where the point was. Are we good with this screen? Should look pretty much like this. Second quit. The mode button has the word quit right up above it. So if you press second followed by the mode button, then it'll get you back to the main screen. I guess it probably would be good for me to show the key press history. As I'm doing this, I just needed to see those. What's next? I want the calculator to draw a picture of this. So press y equals just for a moment. Press y equals. Do you have any equations there when you press y equals? Maybe a linear equation or quadratic equation, something with a radical. If you do, and you're not attached to that equation, you can clear that equation out just so it doesn't get in the way. If you want to leave it there, say if you have like 2x or 2, oops, I can't do that. If you have 2x plus 5 there, and it's really near and dear to your heart, and you don't want to get rid of it, you can move it to the cursors flashing on the equal sign and press enter, and that will deselect that equation. Otherwise, just clear it. There we go. It's gone. I thought it would be gone. Now it's gone. Okay. Have to be on the expression itself. To graph it, I could just press graph, but I doubt that I'll see many of those points. I'm just going to press graph. If this is the standard viewing window, I think it is, there are no points. If you look at these points, not one of these points has x coordinates less than 10 or between negative 10 and 10 or y coordinates between negative 10 and 10, so we don't see them. We could adjust the window manually to fit these in, but when a stat plot is turned on, there's a fast way to do this, and I think fast is a good thing at this point. Zoom 6, no, not 6, zoom 9. Zoom 9, zoom stat. And we see the points. Now to get the calculator to display the equation, well, to find the equation, it's these steps. Follow these steps along with me. Stat button, right arrow to the calculate menu. Notice the calculate menu. Number 4, linear regression equation of the form ax plus b And your X list should by default be L1 and L2. X list L1, X list L2. You might just be able to press enter at this point. If you have the newer operating system, press calculate. Otherwise, just press enter, and it should give you this. Basically, it's telling us the slope is 0.25 if I round that to 2 decimal places, and the y-intercept is 39.52. So I'm going to type in y equals 0.25x plus 39.2, and I can throw in an extra decimal place if I wanted to. But I'm out of time, and then it graphs the line.